for day one, we're talking about GCFs of polynomials. We talked about GCFs a little bit before. Do we remember what a GCF is? The greatest common factor. It's the largest number that can be divided out of a set of numbers evenly. Not evenly. Okay, so we are essentially going to be doing that today, finding GCFs of a set of numbers. Our sets of numbers are going to be polynomials. So not only in a polynomial are there numbers, coefficients and constants, but we're also going to have to deal with the variables. That's the part that's going to be a little bit new for us. So we have two steps to find the GCF of a polynomial. The first step is to take care of any coefficients and constants. Coefficients and constants, those are the numbers. So any number you see in front of a variable, any number that doesn't have a variable at the end, those are my coefficients and constants. One rule that we have for taking out the GCF of a coefficient or a constant is that the GCF is going to be a negative number if the leading coefficient, aka the first term, is negative. So the sign of your GCF, positive or negative, should match whatever the sign of your leading coefficient, aka the first number, is. If it's positive, your GCF is positive. If it's negative, your GCF is negative. Is that clear? Once we take the GCF of the coefficients and constants, then we'll find the GCF of any of the variables. We'll go step by step here. We'll go one variable at a time. And we're going to determine the highest power of the variable that each term could be divided by. I'll show you some examples of what that looks like. We're going to start off in example 1, nice and easy, with 2x plus 2. So first, I take a look at the coefficients, 2 and 2. What's the GCF of 2? Should be 2, right? Nice and easy. Now I look at the variables. I have to be able to take a variable out of all of the terms in a polynomial in order to have it in my GCF. Can I take an x out of this last term right here? I don't have an x there. Therefore, I can't take any x's out. So the GCF of this polynomial is just a 2. In letter B, let's again start by looking at the coefficients. What's the coefficient in front of that negative x? When it's not written, it's a max. It's a 1. So what's the GCF between 3 and 1? 1. That's the biggest number we can take out of each. So there's a 1. We don't usually have to write the 1, but I'm going to write it for now. Then I take a look at the x's. Is there an x, at least one x in every single term? That means we can take it out. So I'm going to look at my x's. What's the exponent on this x right here? This last one. It's a 1. So I look for whatever the lowest exponent is, which in this case is a 1, and I can take out an x to the first. If I take out x to the first in this last term, there's no x's left over. That's what I'm trying to get to. Okay, so you could write 1x to the first. More simplified would just be an x, if you care. All right, letter C, same thing. What's the GCF of my coefficients? 5. And then what about the variables? V to the third. There's a v in each of the terms, so I know I can take out a v. And then I'm looking for whatever the lowest exponent is. That's the maximum number that I can take out. Because I can take 3 out of here, and I can take 3 out of here. I could take 4 out of here, but I couldn't take 4 out of there. So that's the that's the maximum number we could take out, is v to the third. There we go. Questions on that? Okay, we're going to keep going. What about letter D? Starting with the coefficients. What's the GCF of those coefficients? 2. Perfect. What's the GCF of the variables? Can we take a b out of that last term? No. So we cannot take a b out at all. So my GCF of letter D is just a 2. We need to be able to take it out of every single term if we're going to write it. What about letter E? What's the GCF of these coefficients? -1. Why is it negative? Oops. Why is it negative? Because that first term is negative. So anytime that first term is negative, our GCF should also be negative. Those signs should match. What about the H's? H to the second, exactly. So if you wanted to simplify this, I guess we could simplify this to negative H to the second. But either one is fine with me. Okay, last one here. Things get a little bit tricky. Let's do the coefficients first. Hello, red. There we go. GCF of the coefficients? 3. GCF of the x's. Do we have an x in all 3 of these terms? At least one x. Yeah? How many can we take out? The maximum number we can take out of each. How do we know it's 1? The smallest one in here is an x to the first, so that's the most amount that I can take out. What about the y's? Is there a y in each one of these terms? So how many can I take out? What's the max? 2. Perfect. Any questions on that? Can I get 4 different people to do these practice problems? Sarah wants one of them. All right, awesome.